Right, so hi everyone. Thank you for the intro. So like you said, I'm Benjamin. I do some open source stuff. I work at Testim.io. I teach high school once a week, which is really fun. Those of you who haven't done it, try it. I live in Israel. We also have great conferences. And that's about me. This is my GitHub, if anyone wants to check it out. Right, so I'm going to show some data in this presentation. All the data is from internal surveys. It's primarily based on companies in the US and Israel. Everything I'm going to show is significant, as in the t-test, but all the tests are repeated once. So please take everything I show with a grain of salt, and because a t-test with a p less than 0.05 means there is a 5% chance that like any visualization I'm saying is wrong. I am one person. My experience is limited to working on the Testim development kit. That's like the Testim product thing. It is fairly recent, so all the data here is from the last year. Please, before you make any decisions about the way you do automation, evaluate several choices and make your own, collect your own data. Right, so what are we going to see today? We're going to talk about what browser testing is and why it's hard. We're going to talk about AI and ML in a nutshell. That's going to be really interesting to those of you who never did science and a bit boring for those who did. And then we're going to talk about a bunch of applications of AI and ML in testing, very practical applications. So first of all, browser testing. So when we polled a bunch of companies, like over 200 companies, and we asked them, do you have end-to-end tests? Around 85% of them said they don't have an end-to-end tests that are run automatically whenever they finish their, whenever they run their continuous integration. Well, with a raise of hands, who here has good end-to-end tests? All right, that's about 15%, that's good. So that reflects the data we have here. And that makes me sad, right? That's really baffling. Automated end-to-end tests are really useful. We have a lot of bugs in our code, at least I write a lot of bugs in my code. And a lot of us don't have tests. So let's go over the tooling and talk about why it's hard. Now, by far, the most popular tooling for writing tests, according to the survey, is still Selenium. And I think the reason it's popular is because Selenium is super simple. Before I worked in automation, I had no idea, but it's just a REST JSON API. So the really good thing about the REST JSON API is that HTTP is universal. You can write Selenium in any language, you can execute it on any browser, you can execute it on Android, on iOS, pretty much everywhere. So just to show you how simple it is, like making Chrome start in Selenium is just post to /session. That's how simple starting the browser is. And clicking an element is just /click. So it's a bunch of really simple, really not clever API commands, executing script, clicking an element, checking that element text. And it's by far the most popular. And it's by far the most simple, and it's cross-browser, which is a positive thing about it. The vendors still maintain the drivers, and it's cross-device. You can run tests on Android or iOS. It supports most common languages. So I think that's why it's still the most popular test automation tool. And the way, I don't know who here did automation, but when I interviewed 20, 25 automation engineers, they all write tests the same way. They take their site up, they break it to pages, and then they create page objects. That's like a page with a method. So if you have a login page, you will have a login class with a login method. They write a test plan, which is all the things they want to test, and then they use those page objects to implement the test plan. And that's the typical flow of automation. That's the most common flow, using Selenium and doing this. Now, there are two other alternatives I want to mention. There is Puppeteer, which is really nice software. It talks to Chrome using the debugger protocol. And that's essentially the same thing that Chrome driver does. Chrome driver is the Selenium thing for Chrome. And it's more tightly coupled, which means it usually has fewer bugs that are version related. The other thing is Cypress. It's pretty new. And Cypress just does the same thing that Selenium did before they changed the drivers. It executes JavaScript on the page, which has a disadvantage, but also an advantage because JavaScript is easy for me as a JavaScript developer to reason about. So why is it hard? When I polled the same people about the last 3 months, selectors break a lot. When you have an element on the page, and like it has a class, and then you start integrating external teams to your project, it will break. So frameworks that you choose one property, like an ID, a class, a text, tag name, whatever, and all those can fundamentally change without changing the UI. So you can, for example, use React with CSS modules, and on your next build, all your tests will break. And you can add a hook, and then get an outsourcer to do like a new page, and that page doesn't have hooks. So there is a constant overhead in selecting and finding elements on the page. There are a ton of state bugs in tests. So we write JavaScript, which is great because we don't typically use threads. Kind of ironic because I worked on threads in Node, but never mind. So we have a synchronous state in web pages. And I think the most common example of this is React. And in React, state is asynchronous, right? We have a useState hook. useState hook returns state and setState. And when we call setState, it's asynchronous. And React has this thing that sometimes works called control inputs that doesn't work, for example, with rich text editors, that syncs the state, but it's very, very risky. We see a lot of bugs in automation projects that are caused by timing. And test frameworks, what they will typically do, they will do retries and timers, which is inherently flaky, because your CI is not as fast as your computer, and if it is fast, it doesn't always have the fast internet. And if I have like 10,000 tests and like just 1% of them breaks every version, that's a ton of work. Commands are dispatched by automation tools very quickly. So if your page does a resize, that can take, on some big websites, 3 seconds just to clear the JavaScript execution. And tests that rely on the page being ready, JavaScript being ready to execute, that sort of thing, are often flaky. And the bad thing about it is, not that it's finding bugs, is that it's finding bugs that don't happen to real users, which means you are debugging things because of your automation. Now, another thing that is a big challenge is cross-browser testing, right? So Selenium works cross-browser, but browsers still behave differently. And we ended up writing over 50,000 lines of code just to deal with those differences, just to give you an estimate. Now, not only is cross-browser testing hard, cross-operating system testing is hard. The code that happens when Chrome driver dispatches a click, and that's actually the same code that Puppeteer does or other automation tools do to dispatch a click, basically goes, those of you who don't know, whenever you type something into the console, that actually sends a WebSocket message to the debugger, and that has a dispatch architecture, and that does OS-specific routing. In Mac, when you do a click, that will do something called the CG post mouse event, and that's Mac-specific. And there's a bunch of bugs related to that. So your tests might pass on Mac, for example, and fail on Windows, or pass on Windows and fail on Linux. So that's another really big challenge that we have in cross-OS testing. And testing is really time-consuming. So this part shocked me, because I was sure the average number of tests that people write in a day is like 50, but it's like 8. And I even excluded the people who said 0 from this poll, so the number is actually lower. And this is nice, because I trust this result because it's like a Gaussian distribution, which is always makes me happy. But people will write around 8 tests a day, which I think is very hard. And there are a lot of maintenance defects. So writing tests is typically both flaky and slow. When we talked to a lot of teams, when I started to evaluate what to build the thing I worked on, we interviewed a lot of teams using Puppeteer, Cypress, and Selenium. That's the tools I evaluated. And there is a similar, constant, high number of defects that all those libraries have, those frameworks have. And automation still breaks a lot. We are still not in a place where writing automation is easy and not flaky. And I think that's part of why that 85% number exists. But some teams do have automation, right? There's those 15%. Some of them are really happy with their tests. Some of them have really good tests that deliver value that run on their CI. So I wonder why. Because most automation projects still fail. Most companies perform manual QA. In the last company I worked in, I didn't have UI. The company before that, we had manual QA. It was a big cycle. Like, it took several days every time. And that's an absurd situation, because we are programmers. We like automating things and testing them automatically. And that has to change. And no matter who is going to change it, this will change in the next 5 years. Now, to something completely different. Let's talk about AI and ML in a nutshell. So what is intelligence? Like the abstract slide every talk about AI needs to have. So intelligence is just logic, understanding, learning, problem solving, reasoning, creativity. It's not very well defined. Now, artificial intelligence is just intelligence demonstrated by machines. When you talk about AI, there are two types. There is strong AI, which means machines can be actually intelligent, like people. And then there is weak AI, that is, machines can appear to be intelligent, and we are not sure if they're really intelligent or not. So we're just going to talk about weak AI. This is not a philosophy talk. Now, machine learning, that has a way less cool name called statistical learning, is basically just converting experience to expertise. Right? It's a subset of AI where we use pattern recognition to convert experience to expertise. Now, machine learning is typically divided into 3 areas, which we're going to talk about and how to apply to testing. And the most basic and most simple one is classification. We have this graph, for example, showing watermelons, and we want to predict whether a watermelon will taste good. So one axis will be, for example, shape. The other axis is going to be color. And all we have to do is pass a line between them. And everything above the line is a good watermelon, and everything below the line is a bad watermelon. So we have a feature vector that's like the size, shape, whatever we are looking at from the data. And we have the result labels. That's whether or not the watermelon is tasty or not. And we model a hypothesis class. That's, for example, we want to split them with a line, and we learn what the hypothesis is. Now, this might sound complicated, but all machine learning does is it defines a function called the loss function, and then it writes the derivative to find the lowest point, and that's like the way it does optimization. So those of you who did like derivatives in high school and had like, this stuff is useless, I don't know what I'm going to use the math for, this is what it's used for, right? Doing machine learning is basically just writing the derivative, the gradient. It's called stochastic gradient descent. It's really not that complex, like deep networks, just use the chain rule you learned in high school probably, so it's really not that advanced math. Now, the other kind of learning that is pretty useful is called clustering. Now, in clustering, we don't have the results, we just want to find similar things. So, for example, we have articles, and we want to classify them, like we want to cluster them, into subjects. So we want to figure out what articles are about sports, what articles are about computer science, what articles are about and like other topics. And we just define a similarity between elements, and we find the most similar elements. So that's just clustering. It's another form of machine learning. And the third type is reinforcement learning. In reinforcement learning, we have a sequential process of decisions, and we learn as we are predicting. So just real quick, we have classification, that's the first type. We have clustering, that's the second type. And we have reinforcement learning, where we make the updates as we go. And machine learning is all around us, right? We have self-driving cars. We have personal assistants in our phones that use NLP machine learning. Machine learning wins in Dota, which is crazy good and crazy impressive. And our editors, those of you who use VS Code, it uses machine learning in order to give you completion suggestions. That's like a thing Microsoft built. So machine learning is really all around us. It's being used in many places. But how is this practical, right? This talk is about testing changing because of AI. Can we actually apply the things that we just saw? So how did web testing even evolve, right? So the first web browser is 1993, that's Mosaic. And after that, the web started exploding. Now, those of you who did web in 1993 to 2001, the web was very young. And after that, Flash was popular for a while. But the internet exploded. Like we all know this. Software ate the world. The internet grew significantly. And testing was born. Now, in 2001, a tool called Mercury was created. It was acquired by HP Software. And they're the first who did automation on the web. And Mercury, the reason Selenium is called Selenium is because of Mercury, actually. Selenium was the open alternative to Mercury. And that did the automation. And eventually, like, design patterns started, automation grew, and now we are finally at a point in the first time that the number of projects using automation is exploding. We have a lot more automation than we had a few years ago. So, how can we apply machine learning to this graph? So, the first thing I talked to you about is how tests break because of selectors. What if, instead of selecting an element in just one way, we select every element in 1,000 ways on the page, and then we use reinforcement learning to figure out what changes between tests and improve. And that means that when you run your tests multiple times, it will get more stable and not less stable because it understands change. There is, I think, Buddhist saying that change, or like Greek philosophy, that change is the only constant. So this idea relies on it using reinforcement learning. That's the third type, where we select the element in multiple ways, and we actually also select all its ancestors, and then we measure it across runs, and then we adjust the scores as we go. So, for example, you have a page with a pink button, you change it to a green button, and then the test will look at what you're doing and update the scores of the elements. So that's really cool. Now, what you can do without testing, what I saw that works, is you can integrate your build into your test. That's a good alternative, because if you integrate your build into your tests, that will let you, for example, integrate CSS modules. You can select an element in several ways and log the errors, or you can take this idea and just train your own model. It shouldn't be. It took us like 1-2 years. It shouldn't be very difficult for a large company to train a model that does this, and it works pretty well. The other thing we talked about is the low number of tests that that people are writing. And now, this is just an example from the thing I wrote, but you can record tests. And the issue with recording tests is that it didn't work for a long time. We had tools that let you record tests for many years, and those tools just didn't work. But we are seeing a new generation of tools that let you record tests, and that like changes the number of tests you can record a day from like 6 to like 80. The number really grows, and there is like a Puppeteer recorder, and we do it as well, and it deals with the low number of tests, and this is just an interlude, just to address the problem. It's not directly related to machine learning. Now, I want to talk about classification. When we write unit tests, we almost always have some measure of coverage. Like I use Istanbul, I think it's called Nick, that's the CLI, and I get function coverage, line coverage, whatever, so I can tell how many functions my test covers and how good it is. Now, coverage is not really great, and like it's like lines of code. It's like measuring, there is a Bill Gates quote, it's measuring by lines of code is like measuring airplane construction by weight. So coverage isn't always great, but it's a good proxy to know what happens. And what we can do, and what I did, is I took pairs of HTML pages, and I trained a classifier in order to figure out how similar they are. And what it gives you is templating. It's a problem called wrapper induction in data science. And basically, you need to figure out what types of page you have on the site. So like a home page, an article page, a post page, a contact us page, whatever. So you can use classification, the thing we saw before, to figure out what page types your site has and how to use them. Now, clustering, that's the third type of machine learning. Dev teams are notoriously bad at sharing code. And automation teams are worse, typically, at sharing code. And a part of the reason is that people don't really take their tests seriously. They will spend a lot of time thinking about the architecture of their code and not nearly as much time thinking about the architecture of their tests, which kind of makes sense. So you can use clustering. This is just like the thing we do, where you take similar sequences of function calls and you group them together. You extract functions automatically. And the idea is that if you have actions that repeat over and over on your page, you will get automatic code sharing, yada yada. Now, we didn't invent this. There are two interesting scientific papers about this, if anyone is interested reading into it, about clustering source code based on similarity. So I definitely see that in the 3 coming years, we will see this capability inside VS Code and inside, ideally, WebStorm, because this is such a pain. We have refactoring, we have extract function, but extract function doesn't find similar call sites. It just finds exact copies of the code, which doesn't actually help very much. Now, the thing we built is autonomous testing. Autonomous testing, I think, is the direction we will, 90% of our tests will go to in the coming years. And the reason we will go towards autonomous testing is because you can generate a lot of your tests automatically. A lot of you probably have Google Analytics or a similar analytics tool in the website, right? We just take that data and the user flows, and we generate the end-to-end tests based on them. And I think there is like a very low chance this won't be a part of how software testing and end-to-end testing will look in 5 to 10 years. This will be an integral part of how we write our end-to-end tests. All right, I think, yeah, okay, so takeaways. AI is slowly but surely changing software testing. More tools are going to start using ML in AI in software testing. And the big reason is that it's the trend we are seeing, like testing typically follows the curve and of non-testing a few years later. So if we have a trend of using AI and ML in non-testing, that trend is going to come to software testing. And off-the-shelf software testing products are going to move to a model that lets them process your data on the cloud in order to perform machine learning to enable that change in testing and in testing software. Yeah? All right, that's it. Thank you.